This is Bob Capetta, and this lesson is on finding lines of best fit. So let's take a look at what I mean by that. So I'm going to pull up some data that I have here, and it's going to come from what? It's going to come from a recent season of Major League Baseball. So here's the data that I have. I have 2019 American League season. We have the number of wins for each team. So the Yankees won 103 games, the Rays won 96, the Red Sox won 84, etc. And then here I have the run difference. So what does this 204 mean? It means that the Yankees scored 204 more runs than they gave up. The Rays scored 113 more runs than they gave up. The Red Sox scored 73 more runs than they gave up, but the Blue Jays have a negative number. So that means they gave up more runs than they scored. So the negative 102 tells us that the Blue Jays gave up 102 more runs than they scored. They scored fewer runs than they gave up, and they only won 67 games. So you'd expect teams that win a lot of games would score many more runs than their opponents. Teams that lose a lot of games would score many fewer runs than their opponents, hence we would have negative numbers. So we have all these, and we want to go ahead and make a scatter plot. On the x-axis, it'll be the number of wins. On the y-axis, it'll be the run difference. So let's look at that. So there it is. X-axis, number of wins. Y-axis, run difference. So this team out here had 107 wins. That is the Astros, and plus 280. So they scored 280 more runs more than their opponents. Now you may know why they did that if you know something about baseball. But there are our numbers again. Number of wins on the X column and the run difference on the Y. Now looking at this, what does that cloud of points look like? What can we say about that? What's our basic idea? Well, the data seems to lie approximately on a straight line. And you might even be able to hand draw that in. Like, what's the line that best works for all of those points? Just kind of hand draw one in. That's your guess for the line of best, but we want to find it, okay? So our goal is to find that equation of the line of best fit. Now doing that by hand is very tedious, but technology makes that much easier. And in this course, we're going to use the TI graphing calculators to make that happen. So I'm going to go ahead and pull up the TI graphing calculator. We're going to plug these numbers in and see how that works. So TI graphing calculator is over here. And I want to put that data in. So what am I going to do? I have 15 numbers that represent the number of wins, and 15 numbers that represent the number of run differences, positive if they score more than their opponents, negative if they scored fewer. So what do? Stat, edit, and I've got a whole bunch of numbers in that I should clear out. So let's get rid of that stuff that's there. So stat, clear list. So I'll clear list L1, so we'll get rid of L1. L1's gone. And I also had data in list 2, so stat, clear list in L2. Second L2, enter. So now those should be empty. And stat button here, edit, and I can put those numbers in. So I'm going to arrow it over to the first spot. I have 103 wins for the Yankees, 96 for the next team, 84. This is going to be a little tedious. 57, 54, 101, 93, 72, 59, 47, 107, 97, 78, and 72, 68. And I have 15 numbers. That's what it should be. I always like to double check to make sure I haven't made any typos typing it in. So I just take a quick look at that. 103, 96, 84, 67, 54, 101, 93, 72, 59, 47, 107, 97, 78, 72, 68. Looks good. Let's slide it over to the second list. So the Yankees had a run difference of 204. And the Rays had 113. Next up, the Red Sox were at 73. And then the Jays were negative 102. Now, be careful because you have this sign and you have this sign. This sign means minus, must goes in between two numbers. This one means negative. So the negative 102, negative 102, enter. The next one is negative 252. Negative 252. Then we have 185, 112, then negative 124, negative 178, negative 333. That was a rough year for the Detroit Tigers. They only won 47 games, and they gave up 333 more runs than they scored. More than 2 runs a game difference, so that's pretty rough. 107, Astros 280. They won 107 games. They won the most games in the American League this year. Again, you might know why. Next up, 165. Then negative 68. Negative 99 and negative 135. Okay, and again, I'm going to take a quick look to make sure I typed all those in correctly. 204, 113, 73, negative 102, negative 252, 185, 112, negative 124, negative 178, negative 333, 280, 165, negative 68, negative 99, negative 135. Okay, so those are all in. Now what I would like to do is I would like to see the scatter plot. So to do that, we're going to go second stat plot. So let's do that if we can. Whoops. Back to where I'm at. Let me stop sharing for a minute. So I want to go ahead and pull up my calculator again. So I need to go second stat plot. Second stat plot. And plot 1 is what I want. So I'm going to choose 1, enter. I'm going to turn it on, so arrow it over so it's on. List 1 is the X list. List 2 is the Y list. That's good. So we should be solid. Now I'm going to go to zoom stat number 9, and we should see it. Maybe not. Let's try that again. Second stat plot. Oh, it's still off. 1, switch it on, and then hit enter. That's my mistake. Then second, zoom stat number 9, and there you go. So those are the dots. Now we want to find the line that goes through them. We want to find the line of best fit to predict the run difference based on the number of wins. And the calculator does that for us. So watch my procedure here. We go to stat. We go to calc. That's this one, so arrow it over to calc. And linear regression is number 4. So it's of the form ax plus b. A is the slope, b is the intercept. Mx plus b is what you usually think of. So linear regression is ax plus b. And that's the information we want. X is in list 1, Y is in list 2. We're storing it in the regression equation. We want to calculate it, hit enter, and we should get our answer. So what do we get? We get 9.57 is A, and B is negative 775 approximately. So Y is 9.57X minus 775. So we have what we believe is our regression equation. Now let's see what that looks like. I'm going to go to Y equals up here, which enables me to type in the equation of a function. So 9.57x, the x button is here, xt theta n is what I usually use, minus 775. You could also use alpha x for the x button. Let's go back to Zoom stat one more time. Zoom number 9 for stat. And you'll see the line shows up there. So that's pretty good. Now there is a shortcut you could use. Let me show you. There's another way to get that. I'm going to go down to Y2 here and show you another way to get the equation of that regression line. I go to VARS, V-A-R-S. I go to statistics, which is number 5. Enter. You'll notice EQ, that's for the equation, arrow it over to equation. You'll notice regression equation is number 1. I'm going to hit enter, and that's going to drop the regression equation into Y2. Now, it may not look exactly the same as the one above just because I rounded, remember? But you can see the minus 775 is basically there. And then this should be about 9.57x. There you go. So, and if I would want to graph them both, you'll see the lines will likely be right on top of each other. So the blue line was the first one, the red line was the second. Zoom, stat number 9. Here we go, there's the blue line, and then the red line will come in right on top of it, because again, the resolution is such it's not going to be able to tell a small difference out to the 3rd decimal place. Okay, so we have found the line of best fit for that set of data. Now, what can we do with that? Let's do some analysis if we can. So remember, we were here before. We have all of these dots. We asked for the equation of the line of best fit, and we've got it, 9.57x minus 775. Now, what do we want to do with that? Well, what is x and what is y? See, unfortunately, we're not clear on what those mean. Let's redefine them. Y, the second one, corresponded to the run difference. X, the first one, corresponded to the number of wins. So what I can say then is I can say the run difference is 9.57 times the number of wins minus 775. So we get that is our line of best fit to predict the run difference from the number of wins. But what if a team wins 81 games? Now think about that. If you know about baseball, a baseball season, a typical baseball season has 162 games. So if a team wins 81 games, it loses 81 games, the exact same number of wins and losses. So what would you predict the run difference to be? If they win and lose the exact same number of games, the number of runs they give up and the number of runs they score should be about the same. So the run difference should be pretty close to 0. Let's see if that's the case. We're going to plug 81 in for wins. So we get run difference is 9.57 times 81 minus 775. And look how good this number turned out. Run difference is 0.17. That's as close to 0 as you're going to get. So a team that wins and loses the exact same number of games on average is going to score the same number of runs as it gives up. So the number of run difference is going to be pretty close to 0. Okay, let's take a look at another example. Here I have an old class of mine. Some students were very good, like the person who had 96 on the first test, 99 on the second. Some students struggled, like the person who had 28 on the first test and 38 on the second test. So can you predict the results of the second test based on the results of the first test? So what do I need to do? I need to plug these numbers into the calculator. So I'll do that. So I have all those old numbers that are there in L1 and L2. I'm going to clear those out and put the new numbers in there. So let's go back to the calculator. This is what we have. I think I can leave the stat plot on, but I'm going to hit y equals to erase these equations. That equation is gone. And I'm hitting delete or clear. Go down first and clear. That one's gone. Stat, clear the lists. Let's clear L1. Second, L1, enter. Let's clear the second list. Stat, clear list. Second, L2. And everything should be gone now. Now this, again, the stat plot is on because I am going to go ahead and use a stat plot. I'm not going to turn that off just to turn it on again. So I want to put those numbers in. So I'm going to go back to stat, plug the numbers in to edit, which is number 1. And arrow it over to L1 and let's put it in. 88, 92, 86, 76, 74, 28, 78, 70, 96, 30, 68, 54, 74, 32, and 90. And there was 15 numbers again in this list, so I feel pretty good about that. I'm going to take a quick look to see if I put them all in correctly. 88, 92, 86, 76, 74, 28, 78, 70, 96, 30, 68, 54, 74, 32, 90. Looks good. Arrow it over to Y2, line 2, excuse me, 74, then 95, then 88, 97, 38, 77, 75, 99, 42, 52, 77, 63, 54, and 90. And notice I missed one, so I'm going to go back and try to find it. But it's always good to double check your numbers. See if I can find it. Whoops. So 74, 95, 88. I had two 88s in a row. That's what usually happens. 88, 88, 97, 38, 97, excuse me, 97, 38, 77, 75, 99, 42, 52, 77, 63, 54, 90. And now I have 15. I'm going to take a quick check. 90, 54, 63, 77, 52, 42, 99, 75, 77, 38, 97. Now here's the two 88s that messed me up before. 95 and 74. Good. What do I want to do? Let's take a look at our stat plot. So I believe the stat plot is on. Second stat plot, we'll take a look. It is on. It's L1 versus L2, which is good. Then go to zoom stat, number 9, and we should see those dots. Now you'll notice these dots are not quite as tight as the Major League Baseball dots were. Yes, you see a general linear trend, but a lot more deviation from that trend. So what do I do next? I'm going to go ahead and determine what is that line of best fit. So I will do that using stat calc, linear regression number 4, and enter. And line 1, excuse me, list 1, yes, list 2, stored in regression equation, calculate, enter. And And there we go. Y equals 0.73x plus 23.4. And let me go ahead and put in the regression equation. I'll use the shortcut method this time. So I'm going to go, we're going to go to VARs. Statistics is number 5. Equation over, there's the regression equation, enter. So there it is. There you see the point, you see the 23.4 stuff. And let's again go to zoom stat number 9. And there's your line of best fit. So we want to use that line of best fit. How? We're going to answer some questions about it. So I want to go back to our discussion and see where we are. So this is what we had. We had our test 1 and test 2 data. And there was the scatter plot that I received from Excel. Then what can we say about that, right? They do seem to lie approximately on a straight line. Not as good as the first example. We want to find that equation of the line of best fit, which we just did, right? So we were able to get that from the TI graphing calculator. Then what do we say? Test 2, that was the Y value, is 0.73 times test 1 plus 23.4. So let's ask a question again, namely to predict the test 2 score based on a test 1 score of 77. Check that, 87. So if someone gets an 87 on test 1, what do we expect them to get on test 2? Now, we had the data, right? This guy got an 88, which is awfully close to 87, but only got a 74 on test 2. Do you think that'll be our best prediction, or do you think he is an anomaly somehow? So looking at that one identifier for the whole class may not be the best predictor. We have our formula, we have this. So if we have an 87 on test 1, plugging that in, we get test 2 is 0.73 times 87 plus 23.4, which gives us what? Interestingly enough, it gives us about 87 again. So your score on the first test and your score on the second test, at least at this range, tend to be about the same. Now, when is it fair to do these things, to use this model? You want to look at the scatter plot and you want to convince yourself that it's reasonable to consider that they lie on a straight line. If it looks like a circle or a parabola, it's not really fair to use a linear model. But if it looks like it's approximately linear, then the TI graphing calculator is a nice tool to determine what that linear equation will be. You use, again, the linear regression. Takes a little bit of practice to work with the calculator, but I'm sure you are capable of doing it. All right, well, thank you very much.